Now, did you know that both the light that you use in reading for exams and the sunlight are transmitted by waves? They both represent electromagnetic waves. They are waves that consist of vibrating electric and magnetic fields. They transmit energy through matter or across space. Some electromagnetic waves are generally harmless. The light we use to see is a good example. Other electromagnetic waves can be very harmful and care must be taken to avoid too much exposure to them. X-rays are a familiar example. Now, why do electromagnetic waves vary in this way? It depends on their properties. Like other waves, electromagnetic waves have properties of speed, wavelength, and frequency. All electromagnetic waves travel at the same speed through empty space. That speed, called the speed of light, is about 300 million meters per second. Nothing else in the universe is known to travel this fast. The sun is about 150 kilometers from Earth, but it takes electromagnetic radiation only 8 minutes to reach Earth from the sun. If you could move that fast, you will be able to travel around the Earth 7.5 times in just 1 second. Although all electromagnetic waves travel at the same speed across space, they may differ in their wavelength, frequency, and energy levels. Wavelength is the distance between corresponding points of adjacent waves. Wavelengths of electromagnetic waves range from longer than a soccer field to shorter than the diameter of an atom. Wave frequency is number of waves that pass a fixed point in a given amount of time. Frequencies of electromagnetic waves range from thousands of waves per second to trillions of waves per second. The energy of electromagnetic waves depends on their frequency. Low frequency waves have little energy and are harmless normally. High frequency waves have a lot of energy and are potentially very harmful. The speed of a wave is a product of its wavelength and frequency. Because all electromagnetic waves travel at the same speed through space, a wave with a shorter wavelength must have a higher frequency, and vice versa. This relationship is represented by the equation speed equals wavelength times frequency. Therefore, if either wavelength or frequency is known, the missing value can be calculated. Now, consider an electromagnetic wave that has a wavelength of 3 meters. Its speed, like the speed of all electromagnetic waves, is 3.0 times 10 to the power 8 meters per second. Its frequency can be found by substituting these values in the frequency equation. I'm sure you understood the class. I'll see you in the next one.